Let's see this question. We're given this equation with two variables, A and B in it. So we're given this relationship. The only thing we see, oh, that's a type O. So this is B, this is A. There's a type O here. So this is A. This is B. So we see some symmetry here. So this is A square root of 3 minus B squared. This is B times square root of 3 minus A squared equals to 3. So usually a question like this, we want to find out A squared plus B squared. Usually a question like this, we want to use the substitution method. So, right, so let's see. We let this one equals to, we think about something because we want to get, if we want to get rid of the square root, we want to use, let's see, x plus square root of y multiplied by its conjugate, x minus the square root of y. Because in this case, we get x squared minus y. That's how we get rid of this square root. So we call it conjugate m. That would be a square root of 3 minus b squared minus, this is a plus, its conjugate would be minus b square root of 3 minus a squared. Because this whole thing equals to 3, right? We could just call its name 3. So if we multiply those conjugates, we would get the first one square. We would get a square root of 3 minus b square, then minus b square root of 3 minus a square, right? Just like this in this formula. If this will have a square root of x, we will just get x minus y. Right, if outside will have something multiplied by it, we just square that one. So in this case, we got a squared times 3 minus b squared. So we got rid of the square root sign. Minus b squared times 3 minus a squared. And simplify this, we get 3a squared minus a squared b squared minus 3b squared minus plus b squared a squared. That's the same as a squared b squared. You see these two terms adds up to be 0. So we're left with 3a squared minus 3b squared. We can factor out 3. That's a 3 times a squared minus b squared. Okay, so you see we have a beautiful relationship now. We divided by 3 on both sides, so this is a 3m. Divided by 3 on both sides, so m in the end can be simplified as a squared minus b squared. Then remember we do 3 plus 8 because this is 3, right? This whole thing is 3. This whole thing is 3. And the m is its conjugate. So if we add those two, if we do 3 plus m, that would be this plus this. What's get canceled? You see this term is a positive term. And this is a negative term. So those two adds up to be 0. So we're left with the first term, right? A radical 3 minus b squared plus 3a square root of 3 minus b squared. So we get 2 of a square root of 3 minus b squared, right? So we can rewrite, and the m, we have m. So let's rewrite m. So we have 3 plus m is a square root of 3 minus b squared. We're going to use this equation. Minus b square root of 3 minus a squared. So we just substitute this m into its definition, into how it's defined. Then minus, we're going to move this 2a square root of 3 minus b squared to the other side. Minus 2a square root of 3 minus b squared. Well, nothing left on the right-hand side, so equals to 0. So why this is good for us? So we see here, we have, so this is this one minus this one. That's negative, right? So I have 3 minus a square root of 3 minus b squared minus b square root of 3 minus a squared. Let's see will this help us. And this equals to 0. No. We don't want to do this. Why? Okay, this is silly. We already have m has beautiful. We already calculated m. Because this won't bring us anywhere. No, we don't want to do this. We want to do the other way around. Because we already calculated m right here. M equals a squared minus b squared. So we get 3 plus a squared minus b squared. We move this term to the left-hand side as minus 2a square root of 3 minus b squared. That equals to 0, right? Now let's rewrite this. Let's write this as a squared minus 2a. Do you see the beauty now? 3 minus b squared plus 3 minus b squared equals to 0, right? 3 is here, minus b squared is here. You see this one just a square root of 3 minus b squared squared. So this is a perfect formula, right? Perfect square. Because if we call square root of 3 minus b squared some n. So this, if we call this n, and you see this is a squared minus 2an plus n squared, right, equals 0. So that's a perfect square. That's a minus n squared equals 0. And our n is square root of 3 minus b squared. Okay, that's beautiful. So let's just go ahead and do that. So we have a minus square root of 3 minus b squared equals to 0. Well, we're in real number system. Right? We're not talking about complex numbers yet. Real number system. Real number system means if something square, that has to be non-negative, which means the least value is 0. So that forces a minus square root of 3 minus b squared to be 0. 0 squared is 0. Then we move this one to the other side. That's a equals to square root of 3 minus b squared. Then we square both sides. So get a squared equals to 3 minus b squared. Bingo. Add b squared on both sides. Have a squared plus b squared equals to 3. Very nice. So what is the step? The step is we're getting, because our goal is to find a squared plus b squared. So we're getting to a squared and b squared form. And from the very beginnings, we need to free those square terms. Now, how do we do that? We need to get rid of the square root sign. How do we get rid of the square root sign? We use difference of two squares formula. All right, that's it. It's a good question.